In this lecture, we will talk about exponential function. Exponential function. The general form of an exponential function is v of t is equal to va, which is amplitude, e to the power of minus t over tc times u of t. Here, t is time, lowercase t, and the tc is time constant. Time constant. The unit of tc is second, and of course, va is the amplitude. If we graph an exponential function, we will have this graph. Here, the y-axis is v of t. The x-axis, we show it in the form of t over tc instead of t. And here is time units. Don't forget that these time units are not 1 second, 2 seconds. There are t over tc. So whatever is the tc, we divide t by tc and graph the function. And the function starts from point va, which is for time equal to 0, and is in this form. Okay. Here we have a graph for vt, which is an exponential function. Okay, we can see that an exponential function decays. Okay, it decays. It starts from the maximum value at t equal to 0 and decays over the time. Okay, so let's see what's the rate of decay for exponential function. Let's say we want to see what is the amplitude of the function at t equal to tc. T equal to tc. So if the t is equal to the tc, the exponential function will be in this form. V of tc is equal to va e to the negative tc over tc, which is equal to va e to the negative 1 equal to 0.368 va. So it shows that an exponential function decays to about 36.8% of its initial value in one time constant. So if t is equal to one time constant, the function will be decay about 36%. And if we show this decay and this new value on the graph, as we discussed, t is equal to tc, so t over tc is equal to 1. So in the vertical axis, in the horizontal axis, we will have 1. And if we find the value of the signal in the horizontal, in the vertical axis, it is equal to 0.368 va. 368 va. Okay, so What about other points? At 5 time constant, at 5 time constant, in fact, t is equal to 5 tc. The value of the waveform is very, very small. Okay? In theory, exponential signal decays forever. So it never reaches to zero. It decays forever. So at which time the value of this function is equal to zero, at which t, of course, at t equal to infinity, the value of exponential function is equal to zero. But in fact, but practically speaking, when we talk practically, after 5 Tc, the waveform amplitude becomes very, very small. So we consider the duration of an exponential function waveform, we consider it as 5 Tc. We say after 5 Tc, the amplitude of the exponential function is equal to zero. Okay, practically, but in theory, it's not equal to zero. Let's say in theory, what is the amplitude of the function after 5 Tc? If t is equal to 5 Tc, we can say v of 5 Tc is equal to va e to the negative 5 Tc over Tc, which is equal to Va e to the negative 5, which is equal to 0.00674 Va. So we can see that in theory, the VA, the like VT after 5 Tc is not equal to zero. It's equal to 0.006 VA. But because this value is negligibly small, we consider it as zero. And we say that the duration of an exponential function is equal to 5 Tc. So when we talk about the exponential function, we consider that the duration as 5 Tc. Why we multiply it by u of t? We know that the u of t has a value of 1. U of t, if you remember from the last semester, u of t is equal to 1 for t equal greater than 0 and is equal to 0 for t less than 0. So we don't want to have any signal for t less than 0. We start our signals at t equal to 0. So it's the reason why we multiply the exponential function with u of t. We want to like eliminate any signal for negative times or negative t. So we multiply this part by u of t. So as a result, the signal will start from point 0. If we don't add u of t in this function, the exponential function graph will be something like this. So we see that it has values on negative t, but we don't want to like deal with negative times because whenever we do any calculations, the time starts from 0. Okay, so let's see some examples. One example. Here is one example. Let's consider this signal. V of t is equal to 20 e to the negative 100 t u of t. Okay, the first thing we should find here are the, of course, t of c and VA. We know that VA is equal to 20. What about t of c? We know that the power of E is equal to negative T over Tc. So if negative T over Tc is equal to negative 100 T, as a result, Tc will be equal to 10 milliseconds. Okay, Tc is 10 milliseconds. So let's graph this signal. Okay, first we need to have our axes. So it is like VA, and for horizontal axis, this time I want to show it with milliseconds. Okay, so 10 milliseconds is 1 TC, 20 milliseconds is 2 TC, 30 milliseconds is 3 TC, and 40 milliseconds and 50 milliseconds. Okay, if we find the value of the signal at 1 TC, we will have T of 1 TC. Okay, TC is 10 milliseconds. V of 10 milliseconds is equal to VA, which is 20, times E to the power of negative 10 milliseconds over Tc, which is 10 milliseconds, times U of T. Of course, U of T is equal to 1 at 10 milliseconds because it's a positive value. So instead of U of T, let's say U of 10 milliseconds. Okay, so here U of 10 milliseconds is equal to 1, and we will have 20 e to the negative 1, which is equal to 7.358. So at 1 TC, which is 10, we will have the amplitude of 7.358, and the initial signal value, of course, is 20. And after 5 TC, we know that the signal practically reaches to 0. So if we want to plot this signal, we need to plot this signal in this way. Okay. So this one is the graph of this equation. Okay, now that we learned how to graph an exponential signal, let's talk about the time shifting of this kind of signal. Okay, so we want to talk about time shifting. Time shifting. We know that the original signal for exponential function, as we discussed, is V of t is equal to VA e to the negative t over tc u of t. And we plotted, we graphed the signal, so the signal is in this form. Okay. Now, let's shift the signal to the right and left. We know that in order to shift the signal to the right, we should subtract the time with a time a constant value. Okay, so if we consider this signal, V of t is equal to VA e to the negative, instead of t, this time we say t minus t sub s, okay, over tc times u of course, we need to shift all time units, so we say t of t minus ts. Okay, so notice that tc and ts are different. Tc is time constant, but ts is a constant value for time shifting of the signal. If we plot this signal, the signal will be the same signal we have here, but shifted to the right with with the value of ts. Okay, so this let's graph this signal. This signal here we have time, and the signal starts from ts. Why the signal starts from ts? Because we have u of t minus ts. U of t minus ts. We know that u of t minus ts is equal to 0 for t less than ts and is equal to 1 for t equal greater than ts. So for t less than ts, there will be no signal. So we start our graph from ts, and the maximum value of the signal, of course, is VA. Okay, and here is the signal. It starts from ts and goes down. Okay, so the next time shifting which we want to discuss is shifting to the left. So if we have Vt is equal to Va e to the negative, this time t plus ts over tc u of t plus ts. Okay, this time the signal will be shifted to the left. So we start from negative ts, and we will have VA here, and we'll start plotting the signal. So, by the way, at which point we reach to practically, not in theory, practically we can say we reach to 0. Of course, we know that in 5 TC, but because we have shifted to the left, this point will be 5 TC minus TS because shifted to the left. And for the other signal, the point, the cross point between the signal and x-axis is 5 TC plus TS. When I talk about crossing point, I mean practically, because in theory we know that the value of the signal never goes to 0. Okay, it reaches to 0 at infinity. So the second example which I want to show you is here. It says a sketch. The following three functions. Okay, which function? The first function is v of v1 of t is equal to 30 e to the negative t over 10 u of t. Okay, tc is equal to 10, so this big tc is equal to 10. So after 5 TC or 50, we will reach to like 0. And if we plot this signal, here is the plot graph. It's time v1 of t. We start from 30, and the time is 10, 20, 30, 40, 50, 60, and we know that after 50 seconds, we reach to 0. So this one is this v1 function. What about the second function? The second function is v2 of t is equal to 30 e to the power of negative t minus 20, 10, u of t minus 20, because both unit step and exponential function are shifted together with the value of 20. We can say that the entire signal will be shifted to the right within like 20 seconds. Okay, so let's just plot graph this signal. So if we have 10 here, 20, 30, 40, 50, 60, 70, and the signal starts from t equal to 20. So at t equal to 20, the signal starts with the initial value of 30, and after 5 TC, so 5 TC is 50 plus 20, which is the start point, which is 70, the signal will be equal to 0. So the signal is here. Okay, this one is the signal. Notice that this time duration is 5 TC, which is equal to 50. Okay. The third signal, which is V3 of t is equal to 30 e to the negative t over 10 u of t minus 20. So this one is a little tricky, because if we look to this function, we see that the unit step has is shifted by 20, but the exponential function has no shift. So exponential function starts from t equal to 0. So what we should do, we know that the function will start from t equal to 0, but will be cut by this function, and it will be like shown from t equal to 20. Okay, so let's do that. So as I said, the signal is here. So it starts from 0, because as I mentioned, the exponential function has no time shift. It starts from 0. So we will have 10, 20, 30, 40, 50, 60. So the signal starts from 0 like this. I show it with dashed line for now. Okay, this one is the signal. Okay, it's exactly same as this signal. Okay, because we see that the exponential parts are same, and the only difference is u of t. Okay, now u of t cut cuts the signal before t equals to 20. So before t equals to 20, there is no signal. So if we show this time before t equals to 20, for time less than 20, there will be no signal because u of t minus 20 is equal to 20. And the only part of the signal which we will have is this part of the signal. Okay, so we will have this part of the signal. So still 5TC is at 50, and we can see that the start value of the signal is not 30. Okay, because the start value of the signal is equal to 30 at t equals to 0, but u of t minus t0 eliminated the signal for t less than 20. Okay, so what is if we are asked to find the initial value of this signal at t equal to 20? How we can find the value of this signal at t equal to 20? Okay, it's easy. We can say v3 of 20 is equal to 30 e to the negative 20 over 10. So this value shows the initial value of the signal. Okay, this one was our lecture on exponential functions.